This is Mary Montgomery for assignment 7, looking at question 1, create a graphic object class designed to handle shading using texture. So this is our graphic object texture header class. That's very similar to the graphic object color class, just instead of our color private data member and associated set color function, we have a texture and a set texture function. So we need to include our shader, which is our shader texture. We friend it. This is a derived class off of our base graphic object base class. We have all our deleted and default constructors and operators. Then we have our destructor. And then this is our constructor, which we take in a shader texture and a model. And then our set function, set texture, set world, and then render. For private, we need that pointer to a texture, p-texture, and then we have our shader texture as well as world. Looking at our CPP file, our constructor, we just set the texture and the shader. Sorry, we just set the shader. My initial attempt had us taking in a texture, but then I relooked at the PowerPoint, and we are just supposed to take in these two. Destructor does nothing yet. Set texture, set the p-texture private data member to the texture parameter, set world, and then we need to set the world to the shader. We need to send the world to the shader, set the shader texture, then set the model to context and call model class's render function. So we're sending the world to the shader, set texture resource and sampler to our texture that is saved in our graphic object. We're setting our model to context, and we're rendering out the model using the model class's render function. Looking at our dxapp.cpp file, we need to include our shader texture and our graphic object texture classes. We initialize our shaders and textures first in order to initialize our graphic object's texture objects. So we have our shader texture, our textures, our graphic objects, where we set the texture to the textures we just created. Graphic object 5 is initially the same as 3, with the crate texture initially set, also using model 1. Both the models are boxes. 1 has repeated texture and 2 has the 6-phase texture. Initialize our world matrices, set our new graphic object worlds. I'm using my graphic object 4 as the rotating one. And then in draw, we are changing our texture shaders to our P shader texture, and then we can render out our textured graphic objects. So I'm rendering out graphic object 3. If we remember, graphic object 5 was initially the same as 3, so we're going to change that texture and the world so we can test that the functions work, render that out, and then render graphic object 4. So now the texture is a different texture. It's the cube alignment texture. But since we're using the single face texture, it's just mapping the whole cube faces texture, as you can see there, rather than UV mapping it. But there are my textures. Looking at question 2, creating a graphic object class designed to handle color shading using light. So here's my graphic object light header class. We're using the shader color light shader. Again, it is derived off the graphic object base class. Very similar to the other graphic object color and texture classes. Our constructor is taking in the shader and the model. This time it's the shader color light, and the set functions for the world matrix, material, and just render. So I initially had this graphic object class taking in all of the shader functions of the set, directional light, point light, spotlight, and everything. But I don't know, they just really don't make sense to be in here. I feel like if I'm just setting it, those functions we're just calling the shader function versions. So I ended up taking them out. And our private data is our shader, and then I'm also storing the material ambient, diffuse, and specular vectors, as well as the world matrix, sorry. Looking at our graphic object light CPP class, we have our constructor, which we're setting the model, setting the shader, setting the world matrix. Our destructor does nothing yet, setting the world. Set the material vex, we have our set material function, and then render. With render, we're just setting the model to context, sending the world and material to the shader, which we can do since we've got stored material, and then rendering out our model. Looking in dxapp.cpp, we have our model. Now we're using the unit pyramid, repeated texture, and the unit box 6-phase texture for our models. We're setting our shader color light. Our graphic object 3 is the pyramid, 4 is the box. Initializing the world matrix, setting our graphic object worlds, and then setting our graphic object materials. So the hot pink is for the model 1, which is our pyramid. The honeydew, a light green, is for our box. Projection matrix, and then drawing out the scene. So ignore these comments, change to our light shader, then render out our light, color light graphic object. And so these, like I was saying before, initially we're calling the graphic object and setting the directional light through there, but I'm doing it through the shader now because I think that makes more sense. I don't know why the graphic object would have to store the light parameters. So here we are doing it this way. Setting the light parameters, sending the light parameters, and then rendering out the graphic objects. Same with the graphic object 4. So let's see what that looks like. Our colored models and the lights. Awesome, so we can see sunlight reflection. Sorry, I'm so bad at moving this. It's shining on the back of this, so yeah, we can see the light is shining this way, so when the cube gets behind the pyramid, it's getting lit up by this light source. So yeah. Looking at question 3, create a graphic object class designed to handle texture shading with light. So our graphic object text light class. This class is the same as graphic object light, just with the added texture pointer private data member and the set texture method. The shader we're using is our shader color light texture shader, which we created for a different homework assignment. Again, derived off the graphic object base class. We have all our default and deleted constructors and operators. Destructor, our constructor, only takes the shader and the model, our shader color light texture shader. Our set functions are for the world matrix, texture, and material, and then we have our render function. Our private data is our shader, our texture, and then the vex for the ambient, diffuse, and specular material properties, as well as our world matrix. Looking at the CPP file for our graphic object text light class, we have our constructor, which we set model and set the shader, set the world matrix to the identity matrix. Destructor has nothing yet. Set world, we're setting our world with the param. Set texture, set the texture pointer with our param. Set material, setting our material vex with our params. And the render function, we send the world of material to the shader, set texture resource and sampler to the shader, set the model to context, and then render it out using the model class render function. In our dxapp.cpp file, we create our models, again using the unit pyramid and the box 6-phase texture. Initialize our shader color light texture shader, our graphic object, which is now our text light graphic object, 3 and 4. And then our textures, we have an alignment test texture and the dice texture. Initialize the world matrix, matrices, set our new graphic object worlds to the worlds we just created, set our graphic object materials. So again, our pyramid is going to be hot pink with the alignment test texture on top, and our cube is going to be honeydew with the dice texture on top. And then we set our textures. And then when we draw our scene, again, this was kind of the same dilemma as last time. I did not include the set directional light parameter or light parameter functions in the graphic object class because they're just calling the shader anyway. So I have them here in the render or in the draw scene. So we, again, ignore the comment. We're setting our texture light shader to context, setting the cam matrices, and then setting all of the light parameters that we need, setting the eye position, and then rendering our graphic object 3. Do the same thing with graphic object 4. And let's see our hot pink alignment test pyramid and honeydew die. Now with lighting effects. There they are. So let's just back up a bit. We have a light source coming in from this way. We can see it reflected in the pyramid as well as in the die as it passes by this light source. Looking at question 4, modify all of these graphic object classes we just made to incorporate relevant properties on a per mesh basis. So this just means that for our member or private data that they are arrays now. Instead of just one texture, we have an array of textures. Instead of one ambient material, we have an array of ambient materials, etc. So I won't really go into this too much since everything is exactly the same. There's just a few things changed in each class. In this one, we have our set texture. For our graphic object texture class, we have our set texture with just a texture, and then we have a set texture with a mesh num param. And then in our private, we have a pointer to a texture, so we can have our texture array with multiple textures, still have our shader in our world. Looking at the CPP file, our graphic object's texture, we still set the model, set the texture, and since we set the texture elsewhere, there's no need to loop through the different meshes in the constructor, but we do need to create the new texture array of pointers. So we get the number of meshes that we have stored in n, and then create our new texture pointer array of size n. Now our destructors do something because we are creating these arrays, so we need to delete this array that we create. We have our set texture method that will assign all meshes the same texture, or there's not that mesh num param, so we loop through all of our meshes and assign all pointers in our texture pointer array to texture text. With the specified mesh num param, we just set that exact mesh num to the texture, also set in the parameters. First we assert the mesh num is a valid mesh num, and then we set it to texture. Set world stayed the same, and then rendering, we need to account for rendering different textures with each mesh. So what stays consistent over all meshes is the model. We can set that to context, but then inside our loop, we loop through all of our meshes, and for each mesh, we are sending the world to the shader. That world will always be the same, and then we need to specify the texture we're setting with our texture array, and then render each mesh individually with our render mesh call. And then looking at light, same thing. All we really needed to change were these vector arrays now for the ambient, diffuse, and specular materials. Our set functions for the world material, no more color params, include secondary functions for sets that include mesh num param to apply material to specific meshes only. So then we can look in our light.cpp. Our constructor now, since we set the lighting elsewhere, there's no need to loop through the different meshes in this constructor, but we do need to create the new vector array for ambient, diffuse, and specular of size mesh count. Again, our destructor has to delete the arrays that we created using new. Set world stays the same. Set the material vex. This one, since there's no mesh specified, we just set the same material for all the meshes. Set the material vex for specific meshes only when we specify mesh num in the params. So we assert that that's a valid mesh num, and then set that index in the array to that ambient, diffuse, and specular. And then render one mesh at a time. Set model to context, since that's consistent over all meshes. For the shader, we send the world and material using whatever index we're at in the array, and then render whatever mesh we're at again in the array. So that is the light. Now texture light. Same thing. Now we just added our texture array and our ambient, diffuse, and specular arrays, as well as incorporating our mesh num, parammed, set texture, and set material functions. Looking at the CPP for graphic object texture light, our constructor sets the model, sets the shader, creates the texture and material arrays, get the mesh count, and then, same thing we did in our other classes. Our delete, we need to delete those new arrays we created. Set world stays the same. Set texture, these are just copy and pasted from the graphic object texture with the mesh num, as well as our graphic object light. We're just copying over our set material when there's no mesh specified. Set all the materials the same. When there's a mesh specified, we just set that mesh, or that material, mesh. And then render. Model is set to context is consistent through all meshes, then we just render out. This time we call our shader to send the world and material, then we send our texture and resource sampler, we call that, and then render each mesh individually. Okay, then looking at our DX app. This is long, so I'll try to go through it fast. We have our homemade model, which I just quickly whipped up a little ice cream model. We can see it here. There's 4 separate meshes, the cherry, the ice cream, the cone, and the napkin. And then model 2 is just the box, 6-face texture box. So I'll just go through one and then it's kind of like copy and paste it a little bit. So we have our graphic object color, we have our shader color, graphic object color, we set the colors, tan cone, light green, ice cream, red cherry, white napkin. Graphic object 2 is just the cube, so we just set the shader and then the cube is just light blue. Initialize the world matrices and then set our new graphic object worlds. So that's basically the steps for all of them, but here are the new classes. We have our 4 textures for the 4 meshes. We have a brick, dice, test 512, and crate face. Then we create our shaders and graphic objects. We have our shader texture, and we have our graphic object textures. We have our shader color light, graphic object lights, shader color light texture, graphic object text light. So for each of these, we need to set whatever they are displaying. So for the texture graphic object, we are setting our textures, specifying the mesh numbers for our ice cream, and then just setting general texture for our cube. For the light, we need to set the materials. So setting, hot pink, purple, gold, light blue for our different ice cream meshes, and just old lace for our cube. For texture light, we need to set the texture and material. So we're setting our different textures, and then our materials are just white, so we can see the textures as bright as possible. We create our new worlds, and then we set the worlds of all of those graphic objects. And then we move on to the draw scene. So again, we have initially our color shader. So we're setting the shaders first, and then rendering out the objects. It's pretty straightforward. Setting the shader color to context, sending the GAM matrices, rendering out just the color, graphic object 1 and 2. And then moving on to the texture shader, setting it to context, setting the camera matrices. We can just render them out as is, since they don't have lighting effects. For the last 2, we have to add in our lighting effects, which are just called on the shader. So we have our shader color, light, set to context, send camera matrices, and set directional point and spotlight params, and setting the light parameters with the eye position. And then we can render out our light graphic objects. And finally, we have our shader texture light, set to context, send camera matrices, and set the lights of our texture light, directional point spot, send light parameters, and then we can render out our texture light graphic objects. So let's see it all together. Here are our ice creams with our cubes. Sorry, I'm always pressing wrong buttons. So we just have a big light source shining in. We can see the light reflected in just our color light and our texture light, as well as the associated cubes are a little bit lit. We can go to the other side and see from the back. We can see the light reflecting on our 2 lit ice creams, and not lit on our 2 not lit ice creams, as well as lit the cubes. So yeah, there's my lots of meshes, lots of textures, lots of materials.